All right, so number 11. The path of a thrown football follows the graph quadratic function. When the ball is X feet from the quarterback, it's measured along the ground. The height of a particular thrown in feet is estimated in the table below. Okay, so if you look at the table, we have distance, that's our X value, X, and then we have height for our Y value, and then we have all these different points, right? So distance of 25, then we have 26 high. Then we have 50, 44 high, 75, 47 high, 100. This is in feet, not in yards. Or this guy's got a cannon for an arm. And then 125, 34 feet high, and 150 is 10 feet high. All right. Okay. So we are to find out which of the following, A, B, C, or D, A, B, C, or D, has the best equation for this line, right? Or this data. So let's do it. We have, let's see, edit. We're going to input all this data, 25, 50, 75, 100, 125, 125, and 150. All right, 26, 44, 47, 42, 34, and 10. All right, then we're going to go stat over here to quadratic regression. We know it's quadratic because they tell us in the problem, right? The quadratic function. So we go through here and we find out that our equation is going to be 0.0, so negative 0.00725 x squared. I knocked some of that off, so maybe 26. X squared plus 1.13857x plus 3. So which one looks like that? A is 0.012, so that's out of the question. B is 0.009, maybe. C is 0.007, 1.4 or 1.14, which I agree, and then plus 3. So it's definitely C, and then D is positive, so it goes the wrong way. All right. So that is number 11. Number 12. Total field goals made and attempted from some cult out there in College Station are plotted on the graph. Given this relationship, how many field goals would you expect a player to make if he attempts 140? Well, if it's for that team, 0. But I don't see 0 as an answer, so let's try to get this as best as we can. So we look at that data, and let's see. Really, you're just going to look at the data. We have 20, 40, 60, 80, 1, 20, 40. So that's our 100 mark. This is our 140 mark, which is what they're talking about. And then we have a bunch of stuff. We have 20, 40, 60, 80, 1. All right, so this is how many goals are actually made. So this is made, and this is attempts. 20, 40, 60, 60, 80. All right. In between 40 and 60, they had a dot here. This is 20, 40, 60, 80. And then they had a dot all through here between 80, 60, and 80. Oops, I did that dot in the wrong spot right here. Then a bunch of dots between 60 and 80. One was above, 2 were above, and then one was even above that. Okay, and then we have in between 80 and 100 was less than 40, which sounds about right. Okay, and then 120, it was right around 50. So 120 was right around 50. And then like 160 way out here, of course they attempt that many field goals, 160 way out here is like above 80. So you have this general kind of line right here, right? A line of best fit. You try to get that line as best as you can. And then you look at how many would they have attempted at 140. You arrow over to see how many would be, how many would you get, and it's roughly. Let me see here. My line's a little bit different. Roughly in the 60 range according to the graph. So we're going to go with 63, which is B. Number 13. Number 13 says, find a quadratic function that models the number of cases of flu each year, where y was the coefficient of x. Round your answer to the nearest hundredth. Okay, so number 13 is, we're to plug that stuff into stat, find a quadratic equation. Remember, 2012 is actually year 0. 2013 would be year 1. 2014 would be 2, and so on and so on and so on, right? 2015 would really be 3. 2016 would really be 4. And to go along with that, we would do 410, 410, 465, 552, 2, and 657, and then 742. 742. So that's the real information. We're not going to put in 2012. We're going to put in year 0 because they said that's when it starts. It says it's looking for the coefficient of x, not x squared. So really we're looking for b. What is b? This is what that real question is. What is b? So let's do it. Okay, year 0, 1, 2, 3, and 4. And then delete the rest. Then it goes 410, 450, 65, 552, 657, and 742, and then delete that. So now we're going to, it told us it's looking for a quadratic, so we choose quadratic regression, and we're looking for the b. Remember it said the coefficient of x, not x squared, so we want the b, which is 63, and it said round your nearest answer, or round to the nearest hundredth. So it's 63.31. 63.31. We don't round up because it's a 4. All right. Number 14. Force is starting to go. Number 14, after drinking a can of cola, the amount of caffeine in milligrams per person's body after X hours of drinking is given. Find an exponential function that, so it tells us it's exponential, that can determine the amount of caffeine after X hours. So we just want the exponential function. We're going to go back here, edit, change these numbers 0, 2, 4, 6, 8, and 10. Then we have 35, 28, 23, 18, 14, and 11. Then it said it's exponential, so we're going to go over here to expreg. And that's our function. So does it say to round anything? Find an exponential function? Nope. So this is our exponential function, 35 point, let's round to the nearest hundredth place, 35.56 times 0.89. Let's just leave it at 0.89 to the power of x. That is our exponential function right there. All right. 15. How many more do we have? Oh, I might have to make 3 videos. Number 15, use a graphing calculator to find an exponential function that best fits the data. Remember, it said exponential again. And then it says use your function to estimate the value of y when x is 15. All right. Okay. Let's do it. Stat, edit, 0, 10, 20, 30, and 40, and delete. Then we use 750, 600, 520, 450, and 400, and then delete. So we know this is exponential function because it says so in the instructions. And then we are to use this equation. Let's see, we're on number 15. We're using that equation, y equals, I'm going to round here to 913. So y equals 722.913 times 0.985 to the power of x. Let's see. Let me make sure I didn't do anything. Nope, I did everything right. Okay. And it wants to know what is x at 15. So we plug in 15 right there, and we will type in 722.913.985 to the power of 15. And it should give you a number in between the 15 and 20 number, and it does. It is 576 whatever's. It doesn't really say what it is. So it's 576, and it doesn't say to estimate your answer, and that answer is not on there. 1 second. All right, I punched in a few numbers. I think so. Like if you look at the equation or the problem, it says 750, and that is what our a is. That's our initial value. So I changed our initial value to 750, and then it gave me 597. That's not an option either. So I changed it to 0.984, and it's 588, which is closer to a number. So I think the answer is going to be B. So number 15 is going to be B. All right. 16. And the reason I chose B was because the three answers I got all kind of floated around B, 582. All right, number 16, write the equation of a line that's perpendicular to the line perpendicular to y is equal to negative 2x plus 7 and contains, this is old stuff. Remember all this stuff? And it contains that point. Good. Perpendicular to this, we got to flip it and change the sign. So it's going to be, our new m is going to be positive 1/2. And we know that it's going to be y minus y1 equals m times x minus x1. This is our x1, this is our y1. And so we do y plus 11 because it's already negative is equal to 1/2 times x plus 4 because it's already negative. Distribute, and we get 1/2 x plus 2. Subtract 11 on both sides, and we get y is equal to 1/2 x minus 9. So that is our equation. Y is equal to 1/2 x minus 9. Number 17. Number 17 says, write the what is the solution set for the following equation? What is the solution set for the following equation? So it wants to know what is our domain, what is our range, right? So let's see here. You have x squared minus 2x. Oh, no, it doesn't want to know domain or range. It wants to know the two answers. This is going to be a quadratic formula question. We set it equal to 0 by subtracting 8 on both sides, and we get x squared minus 2x minus 8 is equal to 0. Here's our a, which is 1, our b, which is negative 2, and our c, which is negative 8. And we do x equals negative b, which is positive 2, plus or minus the square root of negative 2 squared minus 4 times 1 times negative 8, all over 2a, or just 2. Let's see, this is going to be the square root of 4 plus 4 times 8 is 32. So 4 plus 32 gives me 36. So that comes to 6. So we have 2 plus or minus 6 over 2. 2 plus 6 is going to give me 8 over 2, which is 4. And 2 minus 6 is going to be negative 4 over 2, which is negative 2. So our two answers are 4 and negative 2. So I'd say x equals negative 2, 4. All right, that would be number 17. All right, I'm going to make a very brief video next for 18 and 19.